Let me speak briefly about the Wolff, Kishner and Clemmensen reductions. They both do the same thing. They're both ways that we can take a C double bond O and replace it with two hydrogens. Now these are very harsh processes, very reductive. We're actually taking an oxygen off with a double bond and then replacing it with two hydrogens. The conditions for doing this are pretty harsh. We're talking about 200 degrees Celsius. The solvent diglyme is a solvent that boils at a very high temperature, around about 200 degrees. And that's what it's used for, to get the temperature up that high. And we're using hydrazine here as our amine addition elimination reactant, and then we're using strong base as well in reaction. Now obviously this is not going to be a very useful reaction if you've got base sensitive species hanging off here. But as you can see, the process involves the amine adding to the C double bond O after the OH minus has taken a hydrogen from the hydrazine. Eventually we get down here, we get our imine product as we expected, or it's actually a hydrazone. And then what the most important step is this one here, where we're losing the hydrogen of this nitrogen here. And what we get is the formation of a very stable N2 molecule. And of course the nitrogen gas will end up bubbling away from the solution, and there's no way that the nitrogen can get back in here and the reaction can go back this way. So the driving force for this reaction is the formation of the nitrogen and then its actual removal from the reaction system. And that sort of pulls the reaction through down to this point here. The actual anion we're getting here is incredibly unstable. It's an alkane anion. It will easily take a hydrogen off water. But forming this anion is only possible because we're releasing nitrogen gas to do so. So this is a basic reduction. It's done under very harsh conditions. If you've got base sensitive stuff going on here, then you can always possibly use a zinc mercury amalgam in the Clemmensen type reduction. An amalgam is a mixture of metals, and this is going to be a catalytic mixture that ends up reducing the C double bond O to two hydrogens, just as the Wolff-Kishner did. These are extremely acidic conditions, and I would consider these conditions to be relatively harsh as well. There's no mechanism that I want to share with you for this one.